Our next exercise is Spss 4A. Actually, it is about entrance examination and attendance in the class, and also IQ of students and final marks. Actually, the final marks may depend on your IQ, your attendance, and also your original talent, which is measured through the entrance examination score. Okay, so here I have given a set of 32 students. The data is given and a number of questions are asked. Obtain descriptive statistics of each variable. So in the Spss sheet, I have entered these things. Descriptive statistics means our mean, median, mode, and such things. So what you can do, you can go to descriptive statistics. Variables are here. Of course, sample number not required. All other are scale variables. So IQ, entrance examination score, attendance, final marks. These I have moved to the right side. I don't require frequency table, so I remove it. And now in the statistics, what all you want, we have to decide. Say mean, median, mode, and quartiles, standard deviation, minimum, maximum. All these are descriptive statistics, range. Then you can continue and click OK. So it has written out the answers. On the left side, it has given the labels. On the next column for IQ, the corresponding values. Then entrance examination score, the corresponding values. Attendance, the corresponding values. Final marks, the corresponding values. So it is quite easy procedure to do that. Now the next question here is obtain appropriate graphs for each variable. Now remember that here each of them are scale variable. Okay, appropriate graphs means a histogram would be appropriate. So you can go to the graphs, or you can do it here itself, analysis, descriptive statistics, and frequencies. There also histogram is available in the charts. You can opt histogram. And the statistics, what we have selected earlier, they all remain, should be removed each time. So after removing them, we can come back. A graphs histogram is selected. So click OK. So graphs usually it takes a little time. It is coming up, I think. Because 4 graphs are there, it is taking a little more time. Yeah, this is a histogram of IQ and entrance examination marks, the histogram, there are gaps in it. And again, attendance, this is a histogram. Final marks, this is a histogram. Okay, that is over. Next one. Next question. Recode the variables into 3 categories as low, moderate, and high as per the following scheme. Now 4 variables have to be recorded. IQ, say 100 and 120 are the cutoff points here. Below 100, low, above 120, high, and between 100 and 120, moderate. So we'll do for IQ first, we'll come back after that. Say recoding, I have done earlier also, I don't know whether you remember, we have to go to transform menu and here recode into different variable. Here I'm bothered about IQ, so I move it here. Okay, new variable name, I will give it as IQ group. Okay, and click here to change. Okay, now I have to specify which all old values correspond to which all new values. So I have old and new values. So here I will choose the range. So 0 to below 100 means I say 99. So the value here output variable is a string. Okay, and say it is low. Then you click add. Okay, now 100 to 120, moderate. And then above 120, so 121 onwards, I don't know which is the highest value. Anyway, I'll put a very high value which is beyond what you have in this data set itself. So that is high. So continue and click OK. So go back to the data sheet. Say here it is written. Each one is classified according to the original value. Say original value was 90. It is taken as moderate. Okay. And 80 low. Like that it is done. Low, moderate, high it has come. Now the next one here I have is attendance. Cutoff are 50 and 70. Again, I can do that one. Come here, recode into different variables. So I can these two were remaining. Okay. Now attendance. What was the cutoff, please? 50 and 70. Okay. Attendance group. So change the values. All this should be removed. Okay. So below 50, 49 up to. So this is low. Add that one, 50 to 70. Moderate. Add that. And then 71 onwards. Of course, it was exactly, I should have taken 69. Yeah, anyway, 70 is included there, so 71 I will include here. Onwards up to a very big number. Okay, high. Continue. And this change we have to do and click OK. So go back and see. So the third variable also coded. And lastly, we need final marks. 60 and 70 are the cutoffs. So I'll go there. For final marks, I recode into different variables. We'll remove all these things. Final marks put here. And new name is final marks group. Okay. Now, I think the value was 60 and 70, right? Yeah, 60 and 70. So 0 to 59. And that is low. Oh, these are to be removed 1 minute. Zero to 59. This is low. Add 60 to 70. Moderate. And 71 onwards to some big number. And that is taken high. Continue. Click OK. Go to the data sheet. See that fourth also is classified. Now the next question. Obtain IQ group-wise mean marks. Categorical analysis. So low IQ, what is the mean marks? Moderate IQ, what is the mean marks? High IQ, what is the mean marks? That's the question. So descriptive statistics frequencies. Of course, we have made the selection that just click OK. Final marks. Oh, that I think this is working. Split file based on IQ groups. Click OK. And now go and analyze this one. Yeah, so high group and their mean marks is 73. Low group mean marks is 58. Moderate group, their mean marks is 63. So 3 groups separately we got it. Now, next question, obtain attendance-wise mean final marks. Same way you can do, but please remember to remove the split file which you have created here. Go back there and split file, you remove that one. Okay. So now we can perform the other one. Attendance-wise also, we can split it and perform the mean marks calculation. Obtain EES group-wise mean marks. Again, you can split it based on EES group and repeat the analysis. Obtain the cross tabulation of IQ, EES, attendance, and final marks. So here 4 variable groups are involved. So you want to create a cross tabulation of that. So we'll do that one here. So in the analyze, you will get cross tabs. So these 4 groups which you have created should be used. So EES group in the row, attendance group in the column, and FM group, final marks group in layer 1. And then you click next. In that one, IQ group you can put. So layer 2. Okay. So 1 in the row, 1 in the column, and the 3rd in the layer 1, 4th in layer 2. Click OK. So that table is coming. Say IQ group wise, 4 are there: high, low, and moderate. Now within one particular one we will consider, say IQ low. Again, it is classified with the base of final marks group: high, low. moderate. Okay, and each one again, within that one again, it is classified into low and high. So, and attendance group, high, low, and moderate. So first classification, second classification, third classification here, and the fourth is the column wise, and these are the row totals, and column totals are given at the bottom, total 32 observations. Okay, and now next one, and 8, 9, 10, 11. These are related to correlation and regression analysis. Just we will have a review of that one before we proceed. Say last year, when I was teaching correlation, I have used this example where I have taken the example of a number of students per day, how much hours they are studying. That is first variable. Second variable is marks obtained. Okay, and I have put one variable on y-axis, that is marks, another variable on the x-axis, that is duration of study. So for first student, he studies 8 hours a day, got 10 marks. So 8 hours, 10 marks should be, so here I have to put a dot. Okay. And second student, 6 hours and 5 marks he got. So 6 hours is here, 5 marks, here a dot should be there. Similarly, next one is 4, 4, 4 and 4, here a dot should be there. Likewise, for all the students, we put the dots. Once we put the dots, we got a pattern that is shown by a imaginary line there. And most of the points are in or around that line. And as we move on that line, which shows the trend in that data, as we move from one end to the other, as duration of study increases, the marks also does increase. Or in other words, as one variable increases, the other variable also does increase. This is what we call correlation. And then we have seen if the dots are very close to the line, and if the line is increasing type like this, as one increases, the other also does increase, we say it is strong positive correlation. Next. Again, here we have positive correlation, but the dots are not very close to the line. So we say that this is weak positive correlation. Here, the dots are close to the line, but the line is a decreasing line. As x increases, y decreases. So this is what we call negative correlation. And again, next one, this is a decreasing line, but the dots are scattered a little more, so we call weak negative correlation. And when there is no pattern visible, we consider it uncorrelated variables. And positive correlation, I can give a number of examples: attendance and marks, or education and earning. Better is your education, better is your salary. And income and expenditure. As your income increases, expenditure also does increase. Marketing efforts and sales. More efforts you put in marketing, sales also does increase. Similarly, negative correlation examples: as price increases, the demand decreases. Work increases, leisure time decreases. Age increases, memory decreases. Temperature, when it decreases, sale of wool increases. So here I have given a set of negative correlation examples. And later we said If you draw that scatter diagram, we will get a rough idea. We need to quantify the amount of association. For that, we have suggested Karl Pearson's correlation coefficient. And the formula was this one, which we have learned last year. We have solved a number of problems. But today we are not going to solve this way because we have inbuilt mechanism within SPSS. We'll use that one to solve. So for the time being, we will stop here. There are certain assumptions also connected with that one. Say, or before that, interpreting the correlation coefficient also. Say if R is greater than 0, positive correlation. If R is less than 0, negative correlation. Then if R is equal to 0 or near 0, we say no correlation. Okay. Say for example, 0.05. It is near to 0. We'll consider practically it's no correlation. Now we'll interpret as per the magnitude. Say if absolute value of R is equal to 1, magnitude of R is equal to 1, we get perfect correlation. If R is equal to -1 or +1, if -1, perfect negative correlation, +1, perfect positive correlation. If absolute value of R is equal to 0.5 or near 0.5, we consider it's a moderate correlation. If absolute value of R is between 0.5 and 1, we consider high correlation. If absolute value of R is below 0.5, we consider low correlation. This is how we interpret it. And there are a set of assumptions related to that. That is, level of measurement should be interval level. And again, it should be related pairs. For example, when you have taken amount of studies, number of hours they study, and the marks, say first student amount of study should be paired with first student's marks. It should not be interchanged between them. So it should be related pairs. And then absence of outliers. That if extreme values are there, then that is not good for calculating this. And variables, both the variables involved, x and y, should be normally distributed. And another thing is that a relationship should be linear. And lastly, homoscedasticity is assumed, means shape of the scatter plot should be tube-like. If the shape is cone-like, then homoscedasticity will not be met. For example, if this is that type, then we will say it is homoscedastic. We can calculate correlation coefficient. If this is the type, we call it heteroscedastic. We cannot calculate correlation coefficient there. So we will just stop it here for the time being, and we'll go into the problem. Now here, first question, obtain the scatter diagram between IQ and EES. So scatter diagram, we have to go to graphs here and click OK. Here you have to choose scatter or dot. So the first type you can drag it here. Okay, and first variable is IQ. So drag it here. See that the finger is pointed inside the box, then leave it. It will sit there. And IQ and ES. Okay, drag it here. And again, see that finger is pointed inside the box, leave it there. And then click OK. So this is the scatter plot they have got. And the next question is obtain the correlation between final marks and EES. So we can come here, correlation, correlate bivariate. So here final marks, that is this, and EES, that is this. Okay, click. So here in the correlation box, final marks versus EES, the value is 0.775. Okay, that means there's a strong positive correlation between entrance examination score and final marks. And the next question is, obtain partial correlation between final marks and EES using IQ as a controlling variable. Say intelligence contributes for final marks also, and it also contributes to entrance exam marks also. IQ will be working in both the variables. So if we are controlling the effect of IQ, whether there is a connection between EES and final marks, this is a question. So how to do that? For that we have to come here and again go to the correlation, partial, IQ, entrance exam marks and final marks you put here, and you are taking IQ as a controlling variable and click OK. Now the new box has come. The correlation between IQ and EES is minus 0.01, as good as 0. Means once the effect of IQ is controlled, there is no much connection between entrance exam score and final marks. The next question, obtain a regression using final marks as dependent variable and IQ attendance as independent variables. So here actually there is a multiple regression which is asked. Dependent variable, before that let us have a look at regression analysis. Say last year we have learned that one. From the current slide we will proceed. Say regression analysis deals with the type of relationship that exists between a dependent variable and one or more independent variables. So for example, if x and y is plotted, we get a slope like this. That is one type of relationship. Another x and y are plotted. So here the line is much more steeper, means 1 unit of change here affects only 0.5 units change in y. That is one type of relationship. Here 1 unit of change x affects 3 units of change in y. That is another type of relationship. So study of this, how they are connected, that is what in a regression we are bothered. Whereas in correlation, what we are bothered? We are bothered about the closeness of the points to the line. Here we are bothered about the slope of the line. So regression deals with the amount of impact of one or more independent variables as on the dependent variable. So also it is used to predict the value of the dependent variable when the given of the variable given value of the independent one. And regression again, there is symbol regression where y is a function of a symbol variable. Multiple regression where y is a function of n number of variables. So here one dependent variable, one independent variable. Here one dependent variable, n independent variables. So this is called multiple regression. The question that is asked, this multiple regression. And we have learned a single regression further. We said If the relation is linear, we call linear regression. If the relation is non-linear, we call non-linear regression. And again, we can see the patterns here. Say this is linear regression, this is also linear regression, whereas this is non-linear regression. And regarding a line of regression, say we have assumed a line like this, y is equal to a plus bx. And what is a? A is y-intercept. So that is shown here like this, where the line cuts the y-axis, that is A. And what is B? B is the slope. Means 1 unit of change in x, how many units it is changing in y, that is B. And to calculate that, we have given this formula. We need not remember this formula today because we are going to use the software to calculate. To understand B, again case, say here 1 unit of change results in half unit change. And impact of x on y is small. And here 1 unit of change impacts 3 units of change. So impact of x on y is big. So again, importance of B. Say for example, one application I can say, amount spent on literacy improvement and percentage of increment in the literacy. So after spending 1 crore rupees, how much percentage has improved in literacy rate? That's a question. If the amount is big, then it is worth. If the amount is small, that is not worth. Another question, amount spent on cleanliness drive and improvement in air quality. Say 1 crore spent on cleanliness drive. What is the improvement in air quality? That B value. If it is negligible, it is not worth. If B value is bigger, it is worth. So that is the one thing. And here also a set of assumptions are that true relationship is linear and errors should be normally distributed. Error means from this line, the gap between that point and the line, that's the error. All the error values calculate and check whether they are normally distributed. Again, homoscedasticity of errors, this I have explained earlier, and independence of observations, that is also assumed. Now we'll go to that regression thing. So the question is, line of regression using final marks as a dependent variable and IQ and attendance as independent variables. So here you can go to analyze a regression linear, second one. Final marks should be the dependent variable. IQ is independent variable. Attendance also independent variable. Okay? And then click on this one. So the first is summary statistics, not here the what method was used to calculate. Second is model summary. Third is ANOVA. We require only the last one. Here that point minus 0.962, that is constant A, and here 0.405, that is B1, and 0.316, that is B2. So line of regression will be y is equal to minus 0.962 plus 0.405 x1 plus 0.316 x2. That's the line of regression. So with this, we have completed this one.